Hey everybody, it's Ms. Seifert with a quick review on the basics of scientific method and units of measurement used in science. First thing, our units of measurement for the metric system, or SI, System International, is going to be length meters, mass is measured in the gram, time in the second, temperature is degrees Kelvin or centigrade, and volume is the liter. Our prefixes are kilo, milli, centi, and deci, with kilo meaning 1,000, like a kilometer being 1,000 meters, millimeter being a very teeny tiny bit, 1,000th of a meter. Centimeter, you know what that is. There are 100 of those in a meter. Decimeter we don't use as often, although you will see deciliter, meaning it is 1/10 of a liter. Okay. Scientific method, this is one way to break it down and to remember it. I'm Tad. You're going to identify the question or problem, make a hypothesis, which is your prediction of what will happen. You're going to test, actually run the test, analyze your results, and draw conclusions based on that. Variables are things that you change in an experiment. An independent variable is the one that I change. We typically graph this on the x-axis. So if I change this, then what will happen, dependent being what will happen. This is what you measure, and it's typically graphed on the y-axis. Types of graphs that might be used, sorry about that, we have a line graph this way, and you're going to look down and to the side, and you always want to read the graphs. Bar graph will show you different types of information all in one graph, or a pie graph when your total is out of 100%. Density is mass over volume. You will most likely need this at some point on the test. It's often tested on the earth science exam. It may ask you to calculate density of salt water. It may ask you to calculate density of a rock or to identify the rock based on its density. But typically you're going to see something with density equals mass over volume. Map skills, latitude and longitude. Latitude are parallels. They run west to east or east to west. However, they actually measure north or south of the equator. So these are our lines of latitude. Equator is 0, which puts the poles at 90 degrees, either 90 degrees north or 90 degrees south of the equator. Longitude is in meridians. The prime meridian is here, and it's 0 degrees, and it actually runs through Greenwich, England, but it also runs through a good chunk of Africa. Part of the reason it was placed there is that on the opposite side of the world, you're running through the Pacific Ocean, and therefore your international date line is on the opposite side through the Pacific Ocean. These run north to south, but they measure east or west of the prime meridian. Okay, 180 degrees is the international date line. Map projections. The Mercator projection gives us a good shape, but unfortunately the areas off. Africa is way bigger than the United States, but given this map projection, you really can't see that. With a Robinson projection, you get both good area and good shapes. So you get the shapes of the continent and a better idea of how big they are in relation to one another. Conic is really good for small areas, but that's about it. So we don't see a lot of those. Map reading skills. When we're looking at contour maps or looking at topographical maps, you're looking at connected lines called index lines or interval lines that are equal elevation or equal height above 0. So want to make sure that you understand how those function. They never touch each other. So this is a 0-foot contour line. This is below sea level. This one is above sea level. Okay, so in this case, this 800 is one of our index lines. Okay, over here we've got 700, also an index line. So you can see that there's an interval, 1, 2, 3, 4, 5 spaces between 700 and 800. That gives you an interval of 20. So if this is 700 feet, this is 720 feet, this is 740 feet, 760, 780, up to 800. So when we read this elevation, let's say that this is an island. Obviously 0 is going to be at sea level. If you were to go to this line and follow it all the way around, you would be at 10 feet above sea level no matter where you were on that line. Right here, this is 20 feet above sea level, as well as this one. Okay, and this is 30 feet. So anytime you have what are called concentric circles, circles inside of each other, that indicates a hill. So this is a hillside, a hilltop. Okay, so this would be that same island, but when you see it from the side, let's say you're in a boat away from the island, this is what you would be seeing. Over here with your concentric circles, this is a bird's eye view of that island. Okay, so that's about it in terms of topographical maps. You will probably see one, so be prepared for that.